Here it is visible. If it is visible.
No, sir.
Screen is visible. Now it is visible.
Yes, sir.
So today we will discuss about the shear force and the bending moment. Okay, shear force and the bending moment. Now if you see this suspension bridge, if you see the suspension bridge, this is okay. Then what cables are there? Vertical cables are there. Okay, they are subjected by the tension, and these cables are anchored. These cables to the suspension girders. So beam and girder. What is the difference between beam and girder? Okay, so span of the beam is up to the 10 meter, and girder having span is more than 10 meter. Generally, we will call this is as a girder. If the span is more than 10 meter, then it is called as a girder. Okay, so these are called as suspension girders, and the suspensions cable vertical, they are anchored to the suspension girder. These are subjected by the tensile force. These are suspension cables are subjected by tensile force. Okay, so this is your rigid joint. This is your rigid joint, right? There is nothing but the fixed joint, rigid joint, which will transfer the moment as well as axial forces. Which will transfer the moment as well as the axial forces. So whatever the weight of the girder is transferred through this arch. Okay, whatever the girder having the arch, that arch will transfer the weight of girder to this pier. This pier and pier will transfer to the foundation. Okay, that is a again pier is one of the type of foundation or below the pier. Whatever the structure element is there, the load is transferred from that to the subsoil, right? So this is regarding the how the load is transferred, then how will be the shear force and how will be the bending moment diagram for such type of the structure or any type of the structure, how the load is transferred, how the reaction will become, that is support reaction, that is shear force, and how will be the bending moment will be created. That is we have to discuss in shear force and the bending. So first of all, what is beam? What is beam, right? So beam is a structural member which is subjected to the transverse load. Okay, one element is there, that is a element, the horizontal axis. That axis is called as a longitudinal axis. That axis is called as a longitudinal axis. That axis is called as a longitudinal axis. The load which is perpendicular to the this axis, that load is called as a transverse load. The load which is perpendicular to the longitudinal axis, the load which is to the longitudinal axis, that load is called as a transverse load. That load is called as a transverse load, right? The load which is perpendicular to the longitudinal axis of the beam, that load is called as transverse load, and the member which is subjected transverse load, the member which is subjected transverse load, that member, structural member is called as a beam. That structural member is called as a beam, right? The member which is having axis is longitudinal axis, that axis, that is horizontal axis. The load which is perpendicular to this axis is called as a transverse load. The load which is perpendicular to the longitudinal axis, that is called as a transverse load. And the member that is structural member which is subjected, okay, the transverse load, that structural member is called as a beam. That structural member is called as a beam. That structural member is called as a beam, right? Now, what is shear force and what is bending moment? Okay, so shear force is nothing but it is unbalanced force. Shear force is nothing but it is unbalanced force on either side of the section. On either side of the section, which is parallel to the cross section. Which is parallel to the cross section, right? It is unbalanced force on either side of the section. If you take the section along the span of the beam, right? Then unbalanced force, unbalanced force, unbalanced force. Okay, on either side of the section, on either side of the section, towards left and towards right. Okay, towards left and towards right. Okay, of the section which is parallel to the cross section, which is parallel to the cross section of. Okay, which is parallel to the cross section of the member, that is called as a shear force. That is called as a shear force. That is called as a shear force. It is unbalanced force on either side of the section parallel to the cross section. That is called as a shear force. Then what is moment? What is moment? Moment is nothing but it is a force. It is a product of force into perpendicular distance. Okay. So if the force is horizontal, distance will be vertical. If the force is vertical, distance must be horizontal. Okay, force is horizontal, distance must be perpendicular to force, that is vertical. If the force is vertical, distance is horizontal. If the force is inclined, then for this incline, the distance must be perpendicular. So force into perpendicular distance. Okay, force into perpendicular distance between the line of action of force, between the line of action of force and the point about which the moment is required to be calculated. That is called as a moment. That is called as a moment. Okay, that theorem we have to use by using the Variance theorem. Variance theorem, I think you have studied in applied mechanics, right? So by using the Variance theorem, we will find out the resultant moment or the distance or the you have to find out the resultant also, right? So moment is the product of force and the perpendicular distance between the line of action of force and the point about which moment is required. या पॉइंटला मोमेंट पाहिजे तर फोर्स इंटू परपेंडिक्युलर डिस्टन्स आहे. या पॉइंटला मोमेंट पाहिजे तुम्हाला ए पॉइंटला, सो फोर्स इज अप्लाइड एट बी इंटू डी about point A. Okay, if you require the moment about this point C, then force into perpendicular distance, you get the moment, right? ज्या पॉइंटला मोमेंट फाइंड आउट करायचं त्या पॉइंट पर्यंत डिस्टन्स. ओके, ज्या पॉइंटला तुम्हाला मोमेंट पाहिजे त्या पॉइंट इंटू द फोर्स दॅट यू गेट द मोमेंट. देन व्हाट इज बेंडिंग मोमेंट? व्हाट इज बेंडिंग मोमेंट? राइट, व्हाट इज बेंडिंग मोमेंट? इट इज अनबैलेंस्ड मोमेंट ऑन आइदर साइड ऑफ सेक्शन. इट इज unbalanced moment on either side of the section. बोलो जी. मी थोडं काम लेक्चर मध्ये झालं की कॉल करतो. Okay, so bending moment, it is unbalanced moment on either side of the section. Again, if you take the section clockwise, anti-clockwise. Okay, so it is unbalanced moment on either side of the section in the plane of the beam, right? So that is called as a bending moment. That is called as a bending moment. That is called as a bending moment. Now we have to study what are the different types of load which is coming on the beam. Types of the loads. This is also required. You are already studied in your applied mechanics, but for the SFD BMD also we require this. Okay, study. So types of the load. There are different types of the loads are there. One is called as a point load. Second is UDL. Third is uniformly varied load. In that uniformly varied load, there are two types of load. One is called as triangular load. Second is trapezoidal load. Okay. Then couple is there. Then oblique load, that is inclined load, is also there, right? So first of all, point load. As you know, this is the point load. Okay, concentrated load. Point load is also called as a concentrated load. Point load is also called as concentrated load at particular point. At a particular point. So concentrated load acts at a point at a particular point. Then UDL, uniformly distributed load. Okay, point load is having unit is Newton or kilonewton, right? Then uniformly distributed load, that is UDL. UDL short form is UDL, right? So it is active over the span, that is uniformly varying load. Okay, so uniformly distributed load, it is acting over the wider area. Okay, so rate of loading per unit length. Rate of loading per unit length, that is denoted by small w. Unit is Newton per meter. Unit is Newton per meter. Right. So is equal to, right, whatever the force is applied divided by the span or the distance. Load upon distance, Newton per meter. That is nothing but your UDL. Okay. If you have to find out the point load that you have to convert the UDL into the point load. Okay, that is called as equivalent point load. Okay, if you have to convert the UDL into equivalent point load, then whatever the intensity of UDL, multiply by the span over which it will act. So span over which it will act, that is, you have to convert the UDL into the point load. Next is your uniformly varying load. There are two types. One is called as a triangular loading. Second is called as a trapezoidal loading. Okay, one is called as a triangular loading. Second is called as a trapezoidal loading. Okay, so that triangular loading or the trapezoidal loading, that we have to convert in terms of the point load. Okay, whatever the triangular loading or the trapezoidal loading, that you have to convert in terms of the your point load. Okay, how you have to convert? So for converting the triangular load into the point load, that is a equivalent point load. So whatever the area of the triangle, okay, suppose this is the triangle. So this triangular load is acting over the total span, and the triangular loading having the span is suppose your L1. Okay, and ordinate is also given. Suppose it is a 10 kN per meter, right? Or it will be loading is like this also. It will be like this. So this ordinate is suppose 10 kN per meter. This is your L1. Like this, the load is acting on that particular beam. That is called as a triangular loading. So how you have to convert this triangular loading into equivalent point load? So equivalent point load is equal to whatever the intensity of the load. So if it is 0 here, it is 10. So 0 plus 10 divided by 2. That is the base into height. Okay, so height is 0 plus 10 by 2 into base is your L1. So that is equivalent point load, and it is acting 2L by 3 or L by 3. It is acting 2L by 3 or L by 3. Okay, so depending upon where is the apex. So from that you can find out the where it will be act. So this case, from this point it is acting at a distance 2/3, remaining is 1/3. If the triangular loading is like this, so from this it is acting 2 by, from this it is acting 1/3. Okay, that is the CG where it will act the point load. After converting the triangle to equivalent point load at distance 2 by 3 from this point, that is apex, right? Hope all of you understood. अडचण आहे का? लक्षात येईल? Yes or no? Am I audible?
Yes, sir.
Whether I am audible? Yes or no?
Yes, sir, audible.
Yes, sir.
Right, okay. So this is regarding triangular loading. If there is a trapezoidal loading, that also comes under the uniformly varying load, that's called the trapezoidal loading. So this is suppose A or B, this is your B, and the span is your L. So to find out the equivalent point load W is equal to Okay, 1/2 A plus B into L, half into A plus B, smaller side plus larger side divided by 2 into L W, and where it will act, okay, from the smaller side, that is x bar is equal to A plus 2B by A plus B L by 3 from this point, from smaller side, to B divided by A plus B into L by 3. From this distance, the equivalent point load W is acting. So we have to convert the trapezoidal loading or triangular loading into equivalent point load, and it will act at a certain distance. In this, because if there is a type of load that triangular or the trapezoidal loading, then you have to convert. Then it is easy for all of you that for point load you can easily find the shear force and the bending moment. Type of loading is given, or the trapezoidal, that you have to convert into point load, and that will act at a certain distance from the light. Next is the couple. Well, as you know, okay, this is acting like this in between the span or at the end of the span. Two unequal forces are there. Two unequal forces. These are forces. These are called as a collinear forces. Okay, they are parallel forces. Right? Parallel forces, they forming a couple. Two equal and opposite force. Opposite forces separated by some distance. Suppose D. Okay, that will form the couple. Okay, and the incline load. So incline load having some incline force, and with horizontal will be the angle. So that you have to convert into the horizontal component and the vertical component. Means you have to resolve this incline force into vertical and the horizontal component. That is cos and the sine. Horizontal is cos, vertical is sine. So you have to resolve the incline force into components, vertical and horizontal. Then you have to find out the shear force and the bending moment. Okay, you have to find the bending moment after forming or after calculating the component. So as you know, equilibrium, summation fx equal to 0, fy is equal to 0, and summation of em is equal to 0. These are the three equations of equilibrium. Okay, that you required for this one. Now, types of support. Different types of support. One is called roller support, hinge support, roller support, fixed support, etc. Okay. So as you know, for hinge support, how many number of unknowns are there? Yes, please. For hinge support, how many number of unknowns? For hinge support, how many number of unknowns?
Sir, 2. Hello, sir.
2, sir.
Yes, please.
2, sir.
2.
2, sir.
Which are those?
HA and vertical reaction.
Vertical and horizontal.
Vertical reaction.
Okay.
Yes.
Horizontal. For roller support, how many number of unknowns are there?
One unknown.
Unknown, which is perpendicular to the base. Remember, only one unknown, but which is perpendicular to, right? Then fixed support, how many number of unknowns?
3, sir.
Three unknowns.
3. Right. Vertical, horizontal, and there is a moment. So there are 3 unknowns for the fixed support. For roller support there is 1, and for hinge support there are 2 unknowns. It is inclined. So remember, I told for roller support, unknown reaction perpendicular to base, always right angle to the base. If it is hinge support, then whatever this is perpendicular and there is again horizontal reaction, right? So this the angle is given. From that you have to find out the component of that particular reaction. So there are three types of support: roller, hinge, and the fixed support, right? Then types of beams. Different types of beams. Supported beam. Second is called as a overhang beam. Fourth is continuous beam, and next is a fixed beam, right? So and one another there is a proper cantilever beam also. Okay. So these are the beams.
Sir, voice
Simple
break
support, as you
while.
know. Voice break while है.
Yes, sir.
है तो आवाज क्लियर?
यस सर, अब आ रहा है सर.
No. Is it visible? Is it visible? Is it visible?
Screen is visible, sir. Hello,
Is it
sir.
visible?
Visible, sir.
Yeah, thank you. So now types of beams. Simple supported beam. Both the end it is simply supported there. Maybe one end is support. Then cantilever beam. Other is free. Okay, one end is fixed, other is free. Property cantilever fixed, other end is a free end. Sorry, simple support end is simple support cantilever. This cantilever beam, one end is fixed, other is free. For proper cantilever, one end is fixed, other is simple support. Then beam with overhanging beam. Okay, one end is fixed, other is simple support, and breathing portion is cantilever. So this portion is called as overhang. This is beam on both sides. There is overhanging portion or simple beam. One is overhang. Okay, like this. That is called as overhang beam. Fixed beam. Okay, both ends are fixed. Beam, both ends are fixed, right? And continuous beam. Okay, the beam which is continuous over the number of span. The beam which is continuous over the number of span. That is called as a continuous beam. That is called as a continuous beam, right? So these are the different types of the beams. Now we will proceed for shear force and the bending moment, right? Because we must know the types of beam, we must know the types of loading, right? We must know the types of supports before going for shear force and bending moment. Because and why we are studying this or for shear force bending moment for simple supported beam or cantilever okay, or fixed beam. For all types of beams, we have to find the SPMD. Okay, then type of support also we require. Okay, then type of loading, which type of loading it is, how it is converted from one form to another form. That also we require before calculating the shear bending. Both shear force and bending moments are vector quantities. It is magnitude as well as direction. Vector quantity. It is having magnitude as well as direction. For conversion, requiring a conversion of signs, positive or negative sign, in order that the values of opposite cells may be separated. So mathematical signs that you have to consider for calculation of values, okay, and it is becomes necessary to use the sign convention. So sign conventions for shear force and bending moment. So shear force symbol is V. It may be used Q or it may be used S. symbol for shear force is VQS, whatever you can use. Now, if you consider this is case, left side, right side upward, so that is considered as a positive. That is considered as a positive sign, and vice versa, left side upward, right side downward, then it is considered as a negative sign. Remember this. Okay, it is Newton or kilonewton. Then for bending moment, there are two types: hogging and the sagging bending moment. Okay, hogging and the sagging bending moment, right? So tension, bottom fibers in a tension, is considered as a hogging bending moment. Okay, the inclination towards left clockwise and towards right anti-clockwise. Okay, towards left of the section and towards right of the section. Right, towards the left of the section and towards the right of the section, clockwise, and so that is taken as a positive. Hogging is taken as positive, and top fiber, okay, it is in a tension. Top fiber, it is in tension. So towards left there is movement, and towards right, okay, left of the section and right of the section, then there is a sagging moment taken as a negative sign. Newton meter or kilonewton meter. Okay. Bending moment, right? Sagging moment, sagging and the hogging toward the left, shear force, okay, downward positive, rightward of the section left la, okay, whatever section you have taken, okay, that is positive, and left of the section, if it is upward section,
Hello, sir.
hogging, positive, sagging, harm.
Sir, voice break व्हायला sir. Hello, sir.
Voice break.
सर तुमची
हाँ,
व्हॉइस
voice
खूप ब्रेक
व्हायला
होते.
का?
हाँ.
हा येस सर.
Now it is audible.
Yes, sir.
येत नसेल तर मध्ये मध्ये सांगा. Whether it is visible.
Yes, sir.
Right. So now beams in bending. Beams in bending. So shearing force at any transverse section. Shearing force at any transverse section. Okay. मी आपण स्टार्टिंगला डिस्कस केलं. The load which is perpendicular to the longitudinal axis, that load is transverse load, and the member is called as a beam. Okay. So the any transverse section in a loaded beam, okay, the shearing force is the algebraic sum of all the forces, acting on one side of the section. Okay, means whatever the section you have taken, section XX you have taken. Okay, so shearing force is the algebraic sum of all the forces acting on one side, on either side, acting on one side or either side of the section. This is your XX section, right? So whatever the forces which is acting on one side, okay, algebraic sum of that is called as a shearing force. Okay, so now if you consider left of X means left of the section XX. So upward is acting RA, RA is acting upward. Okay, so that is taken as positive. Then downward is taken as a negative. So RA minus V1 minus V2 minus V3, that is your shear force, which is left of the section, which is left of the section, right? And right of the section, right of the section, right of the section. Now RB is acting upward, that is negative, and V4 is acting downward, which is positive. So right of the X, right of the section, QX is equal to minus RB, which is negative, left of the right of the section. Okay, upward is negative, downward is positive, right of the section. So shearing force is equal to minus RB plus V4. So that is nothing but the shear force. That is nothing but the shear force left of the section and the right of the section. Is it understood, all of you? Is it understood, all of you?
Yes, sir.
Yes, sir.
Right. Now for bending moment. Now for bending moment. Now for bending moment. Again, we will take this section XX. We will take the section XX, right? Then working on the left of the section. Working on the left of the section. So bending moment about X. Moment about X is equal to R into A. Force into perpendicular distance. R into A minus V1 into A1 minus, that is anti-clockwise moment, minus, and this is a clockwise. So it is a positive, it is negative, right? So RA into A distance, force into perpendicular distance, force is vertical, distance is horizontal, right? So RA into A plus, sorry, minus V1 into A1 minus V2 into A2 minus V3 into A3. All these V1, V2, V3 are creating anti-clockwise, so negative towards the left of the section. Okay, towards the left of the section. So you get the moment about the section X. Then towards the right of the section. Okay, this is creating the anti-clockwise, so it is taken as positive. And it is creating clockwise, so it is taken as negative. To the right of the section, to the right of the section, so is equal to Mx is equal to Rb into B minus V4 into A4. So like that, you have to find out the shear force and the bending moment. Is it understood? Any difficulty, please? Is it understood, all of you?
Yes, sir.
Right. So please remember the sign convention: left of the section, right of the section, for shear force and the bending moment. For shear force and the bending moment. Now, what the things you have to remember to drawing the SFD and BMD diagram? SFD आणि BMD diagram draw करताना काय point लक्षात ठेवायचे that you have to study now. Start from right hand section. Start from right hand section, right? Then use the sign convention of the side which you are choosing, right or the left, as we discussed in previous slide, right? If the things are complicated, then use other side of the section, right? Then start from 0 and end to the 0 also. Means from one support to the another support. Bending moment at the end will be the 0. That is for simple support. End point of shear force will be equal to and opposite of the reaction of that point. Correct. कारण RA वरती जात असेल तर तिथलं तुमचं जे असेल ना तर shear force diagram जर अशी जात असेल तर इथे जे magnitude आहे 10, this is also equal to 10. Okay. Mark, draw the diagram considering the type of load. Okay. Depending upon the type of load, okay, mark the points and draw the diagrams. And at the change in nature of force, right? there will be the 2 points in shear force diagram. At the change in the nature of the force, there will be the 2 points in the shear force diagram, right? UDL is there, or point load is there, right? Or simple UDL is there. So there is the 2 point up and down. Okay. At couple, there will be the 2 points in bending moment. असं जर असेल तर एक खाली जातो, एक वरती जातो आणि एक असं येईल. कारण सपोर्ट रिएक्शन मुळे इथं मोमेंट येतं. ते एक मोमेंट आहे आणि कपलचं एक मोमेंट will be like this for the couple. Okay, this is only additional load असेल तर diagram may be changed, right? So beams are assumed straight, horizontal, and of uniform cross section structure unless otherwise, right? Beams are assumed are always straight, horizontal, and of uniform cross section in the structure unless otherwise specified. Self-weight of beam is neglected unless it is mentioned or unless it is defined. Okay, self-weight of the beam is neglected, okay, unless it is defined. Then shear force may be maximum at support or under the point load. Remember this also. Shear force is maximum at support or under the point loads, or where shear force is 0, where bending moment is maximum. जिथे maximum bending moment असेल तिथे तुमचा shear force 0 असतो, right? Shear force 0 कधी असेल जिथे तुमचा bending moment maximum असेल. Okay, and bending moment will be maximum when shear force is equal to 0, right? Or vice versa, or where shear force diagram will changes its nature, then the bending moment also you get the maximum value. With a shear force diagram, positive to negative, at that particular point also you get the maximum bending moment. Okay, where the bending moment change is known as point of contraflexure, okay, or point of inflection, where the bending moment changes the nature from positive to the negative, okay. This is called as a point of contraflexure. Okay, ज्या पॉइंटला बेंडिंग मोमेंट तुमचा 0 असेल, that is called as a point of contraflexure, or point of inflection. Is it understood, all of you? Any doubt? Okay, take down this numerical. Okay, take down this numerical. Okay, thank you. Take down this numerical and try to find out the shear force and the bending moment, and try to draw the SFD and BMD. So now which type of beam is given? कुठल्या टाइपची बीम आहे? C and E ला सपोर्ट आहे. AC overhang आहे. EB is also overhang. So which type of beam it is? This overhanging beam. Okay, so at free end at 20 kN load is given at point D, 70 kN load, and at free end at point B 20 kN load is there. So there is a support reaction at C and there is support reaction at E. So we will take the section here. Okay, that is XX section. So as a symmetrical loading, so RC is equal to RE. So 20 plus 70 plus 20 divided by 2. Current total load आहे symmetrical आहे 1 meter left right, and span is 2.6 meter. 70 kilonewton is load is applied at a distance of 1.3 meter from both the support. So RC is equal to RE is equal to 20 plus 70 plus 20 divided by 2 is equal to 55 kilonewton. You can check, or you can find out by using the equations of equilibrium also. RC plus RE is equal to 1110. Okay, then taking the moment about any point, you get the value of any one reaction. Okay, so RC and RE is equal to 55. Now shear force. Now we will take right side, then we will take the left side portion. So shear force at B is equal to, at point B. So it is a downward negative, upward is positive, towards the right of the section. Towards the right of the section, downward negative, upward positive. So RE is equal to 55. So at B is 20 only, downward negative. At point E, so it is 55 minus 20. 55 minus 20, that is 35 at E. Then towards the left of the section, so minus 20 is there, minus 70 plus 55, you get that minus 35 kilonewton at point D. Then at point C, minus 20 plus 55 minus 70 plus 55, that is for RE. Then you get the shear force at C is equal to 20 kilonewton. When bending moment at E, so 20 into 1, 20 into 1, that is minus 20 kN meter. So bending moment at D, right? Point D. So 20 into 2.3, 20 into 2.3 plus 55 into 1.3. 55 into 1.3, that is bending moment at D. Then bending moment at point C. So considering the right portion of the C, so 70 into 1.3, right of the section, clockwise negative, anti-clockwise positive. So 70 into 1.3, then 55 into 1.3 plus 1.5, that is anti-clockwise positive and clockwise negative towards the right of the section. So 20 into 1.3 plus 1.3 plus 1. So you get the bending moment at the C. Is it understood? लक्षात आला? काय अडचण असेल तर प्लीज विचारा. कुठली व्हॅल्यू कळाली नाही का ते विचारा. येस प्लीज.
सर हेलो सर.
हाँ बोला.
हेलो सर. सर एट पॉइंट से बेंडिंग मोमेंट
yes,
कैलकुलेशन का एट पॉइंट सी सर बेंडिंग मोमेंटचं कॅल्क्युलेशन कळालं नाही सर. बेंडिंग मोमेंट
point
सी आहे
C
ना
ना?
सर. हा यस सर.
हो तुझा आवाज येतोय.
एट
पॉइंट
सी
सी
सर.
ला बेंडिंग नाहीये असंच ना?
हा सर.
आता सी ला काय घेतलं मी बेंडिंग मोमेंट घेताना टुवर्ड्स द राईट जेवढे लोड आहेत सीच्या राईटला जेवढे लोड आहेत दॅट आय हॅव टेकन. ओके. तर आता इथं सी ला घेताना राईट ऑफ द सेक्शन आहे क्लॉकवाईज निगेटिव्ह anti-clockwise positive. ओके, तर आता सी ला राइट ऑफ द सेक्शन आला 20, हा आला 20 into total distance आहे 1.3 plus 1.3 plus 1, so that is here minus as clockwise negative towards the right of the section. Then this is a 55 reaction. It will create anti-clockwise, that is positive towards the right of the section. So it is a
Yes, sir.
positive towards the right of the C, towards the right of the C. So 55 into 1.3 plus 1.3. And at last, 70 will create the clockwise moment towards the right of the section, that is negative. Towards the right of the section, that is negative. So 70 into 1.3. Is it understood now?
Yes, sir. Understood. Thank
Right.
you, sir.
Okay. So now this is the bending moment, right, towards the point or towards the section. Now bending moment at point X, about this, right, about this. So we will consider the right part of the point F. We will consider right part of the point F. So there is a RE, that is 55 kilonewton is there, and 20 kilonewton is also there. So 20 into 20, this is your A plus 1. So total distance at this point, so 20, okay, into 1 plus A, right? Then 55 into A, clockwise negative, anti-clockwise positive, towards the right of the section. So this is the point of contraflexure. Towards the right of the section, clockwise negative, anti-clockwise positive. So minus 20 into A plus 50A. So 35 minus A is equal to minus 20, that you have to equate to 0. So we get the distance A is equal to 0.57 from point E. From point E, point of contraflexure is located at a distance of 0.57. For that, what we have taken? We have taken the right side of the point of contraflexure, and at point of contraflexure, bending moment is equal to 0. So that we have to equate, and we will find out the distance, that is A. Is it understood?
Understood.
Is it
Yes, sir.
understood? Right.
Yes, sir.
Right. So this is your UDL. UDL is converted in point load, as I told. Now, can you please solve this? At the bottom, there is a sign convention also is there. At the bottom, you can see the sign convention, left of the section, right of the section, or left of the point or right of the point, whichever the point you have taken, left and right of that particular point. So please try to find out this shear force bending moment. If any doubt, I am here. So please try to find out the value. Check whether your value are matching with the value which is on a screen. Please try it. Simply supported beam, 2-point loads, and one is UDL. So as I told, UDL is converted into point load. That UDL multiplied by the whatever the span of the UDL. 20 into 2, that is a 40 kilonewton. It is acting at a distance of 1 meter from point D. Please try to find out whether values are correct or not. If any doubt, values are came, you can ask me. Please go through all the values. Please, this numerical, this is just for practice. If those who are known, those who don't know, they are having to learn. ज्यांना माहित नाही त्यांच्यासाठी हे शिकणं आहे, ज्यांना माहित आहे त्यांच्यासाठी हे प्रॅक्टिस आहे. If any doubt by solving this SFD BMD values, you can ask me if any problem, any doubt. प्रॅक्टिस आहे, ज्यांना येतं त्यांनी न बघता सॉल्व्ह करा आणि ड्रॉ करायचा प्रयत्न करा SFD BMD. It is for your practice. Those who ज्यांना माहित नाही येत नाही त्यांच्यासाठी लर्निंग आहे. If any the value by taking sign positive, लाईनच्या खाली निगेटिव्ह, लाईनच्या वरती पॉझिटिव्ह आहे व्हॅल्यूज फॉर बोथ shear force and bending moment. First find out the value, left of the section, right of the section. At the bottom of this slide, you can see the sign convention. First two are for shear force and second two are for bending moment. If any doubt, you can ask. कुठली व्हॅल्यू कळाली नाही सर, पॉझिटिव्ह निगेटिव्ह, ते पण विचारलं तरी चालेल. आय विल एक्सप्लेन. प्लीज म्यूट. इफ एनीवन इज अनम्यूटेड, प्लीज म्यूट. Yes, please try to do the calculation. If you don't understand how the values are came, you can unmute yourself and please ask. Please mute. Yes, is it over? Is it understood? Try to draw the shear force bending moment diagram. जे व्हॅल्यू तुम्ही कॅल्क्युलेट केला लाईनच्या खाली, सॉरी निगेटिव्ह व्हॅल्यू असेल तर लाईनच्या खाली असेल आणि लाईनच्या वरी असेल तर पॉझिटिव्ह. So 1125 at B, so up झाला. Then there is no load between B and C. इथे तुमचं RBI अप 112.5 आहे, पॉझिटिव्ह आहे, वरी आलं. नंतर बी आणि सी मध्ये काही लोड नाही आहे, सो देर इज अ हॉरिझॉन्टल लाईन. In between B and C there is no load, so it is horizontal. Now it is 112.5. Then there is a 100 kilonewton load is at point C, so downward, so it is down. So remaining is now it is 12.5 at this, right? 12.5 you can see here. Then if I am going from right side, so RA is 77.5, so it is there is a negative reaction, I think. Okay, that is up. So this is your 77.5. Then there is no load between A and E. Then there is a 50. So remaining is your 27.5. There is no load again, and there is a UDL. So for UDL, shear force diagram will be inclined. Shear force diagram will be inclined. So you connect these lines. Similarly for bending moment, at E, at D, at F, at C, and at B. So whenever there is UDL, there is a sharp curve, parabolic curve you have to draw, and for the horizontal line there is inclined line for bending moment. Remember, जर त्या दोन पॉइंटच्या मध्ये जर लोड नसेल तर बेंडिंग मोमेंट डायग्रामची जी लाईन असेल ते इन्क्लाइन लाईन असेल डिपेंडिंग अपॉन द व्हॅल्यूज. आणि जर तिथे यूडीएल असेल देन यू हॅव टू यूज द पॅराबोलिक कर्व. ज्या पोर्शन वरती यूडीएल आहे त्या पोर्शन वरती बेंडिंग मोमेंट डायग्राम यू टू ड्रॉ द पॅराबोलिक कर्व. Is it over? Is it understood? लक्षात आलं? काय डाऊट आहे? Yes, please, all of you.
No, sir.
No doubt. So take this numerical for your homework, or you can try this. Draw the diagram only. Draw the diagram. There is a couple is acting at point C. Couple is acting at point C, 40 kN. Please take down this for your practice for homework. Please try to solve. Please take down this. UDL with couple. So try to draw the shear force diagram and bending moment diagram. There are 2 points as we discussed in the bending moment diagram because there is a couple. 2 points in the BMD. At that particular point, तुम्ही C ला बेंडिंग मोमेंट डायग्राम ड्रॉ करताना तिथे बेंडिंग मोमेंट डायग्राम मध्ये 2 पॉइंट येतील ड्यू टू द कपल. यूडीएल असेल तर कर्व आणि जर स्ट्रेट लाईन असेल नो लोडिंग असेल तर इन्क्लाइन लाईन. शेअर फोर्स मध्ये यूडीएल असेल तर इन्क्लाइन आणि लोडिंग नसेल त्या पॉइंट मध्ये तर हॉरिझॉन्टल लाईन. डायग्राम इज ड्रॉन. The diagram is drawn, all of you.